Hi, I'm Dan Klingman with the Lincoln Electric Welding School. Today we're going to go over some troubleshooting of our welds, and we're going to look at some of those variables that may cause our welds to be, either convex or concave, or maybe not quite as uniform, maybe have some holes in them, porosity. So we're going to start with a couple different variables that we can use to start troubleshooting. And one of those is going to be too low of current. Now, we're going to be using a 6013 electrode. So that's a 60,000 minimum tensile, 1 for all position, and the 13 says that it's a rutile coating. The recommended polarity is AC, but it also can be used on DC. Typically the primary current is the first one listed. So, and our current range on this could vary from 90 to 140 amps. We're going to put it down at the low end and simulate too low of current and see what happens to our weld, and we'll look at it and go from there to what changes we need to make. It was very difficult to try to keep that arc lit. The slag was really crowding our arc, and this is a drag electrode, so we're just going to drag the electrode on the plate. But at that lower current setting, the slag was really crowding the molten puddle, and eventually we made it a little ways and it actually stuck to the plate. So let's see what we have here. So if we look, we can tell that it was really cold. Our weld is very convex, ropey looking, and it should be wet out a lot better than that. So we're going to go ahead and make some changes and see what we can do to improve that weld. We've made a weld with our 6013 at the low end of the setting. We were at 90 amps, and we can see that our weld was very convex, very little penetration in our base material, and a very narrow looking weld. Now we're going to go ahead and go to the high end of the range. We're going to have the machine set at 150 amps, and we're going to make a weld and then go ahead and troubleshoot and look and see what the outcome is at that point. Okay, so now we made a weld at 150 amps, and if you look, we can compare the two welds. The bottom one is at 90, and the top one was at the high end of the range of 150 amps. So ideally, we would probably be right about in the middle somewhere, maybe 125, and we would get it right. So you'll notice a little bit of extra additional spatter as well, and the weld is a little bit wider. Now, we've looked at too low a current, too high a current for our troubleshooting of our welds. Now we're going to go to too slow of a travel speed and too fast of a travel speed. Remember, with arc welding, the whole idea as a welder is to watch that puddle and read that puddle. That puddle is going to tell us whether we need to speed up, slow down, so that puddle is going to tell us exactly what we need to do. So we're going to go ahead, and we've got the machine set at 135 amps, and we're going to go ahead and make a weld that would typically be considered too slow of a travel speed. So we made our weld, and very slow travel speed. You can see how the weld is really wide and it's really high and build up onto the plate. Now the next variable that we're going to look at for troubleshooting a weld is too fast of a travel speed. We just made one at a real slow travel speed. Now we're going to increase our travel speed and looking to see what the outcome of that weld is. So we just made a weld with that 1/8 6013 electrode. The same setting as we made the first one, too slow with travel speed, 135 amps, but now you'll notice how skinny that weld is and we were actually outrunning the weld puddle. So that's telling us that we need to slow down just a little bit and we'll achieve the appearance that we're looking for a proper weld. The final variable that we're going to look at for troubleshooting of SMAW welds is going to be arc length. Arc length is a critical variable for SMAW. That's going to be the distance from the tip of the electrode to the work or the part that we're welding. As that arc length gets longer, our voltage goes up and it causes the weld to really spread out, but it also causes excessive spatter. So we're going to look at the differences between the two. We're going to start off with too short of an arc length. So I'm going to take the electrode, I'm still at 135 amps, and I'm still going to be using the drag technique, but I'm going to be burying the electrode in a really, really tight arc length, which again is going to keep our voltage low. So if you noticed, I was actually pushing down on the electrode and really trying to keep it in close to the plate. And you'll see that it kind of made a convex looking weld, a little bit humped up there in the middle. Next, we're going to make an SMAW weld with our E6013, and we're going to hold a long arc length. Again, as we increase our arc length, our voltage is going to go up. That's going to allow our arc cone to become real wide and long, and you're going to get excessive spatter and you won't be able to get the follow of the puddle. So we're going to go ahead and demonstrate that now. Again, everything else being the same, 135 amps, a drag technique. It's just a long arc. Now you'll notice with that long arc length that we held, yeah, it spread out the weld a little bit, but we also got a lot of spatter. And you'll notice too that the weld is real flat, but it's very inconsistent too in the way that there's not much buildup and very inconsistent in the ripples on the bead. Now the last weld we're going to make is we're going to put all these variables that we talked about for troubleshooting our welds together, and we're going to try to maintain the proper arc length, the proper travel speed, and proper current. And we're going to go ahead and try to make a consistent weld with those proper variables now. So we finished up our weld. And you'll notice too, a good sign that you kind of have your variables correct and for troubleshooting is that the slag will tend to come off a lot easier than it did when your variables aren't correct. So now our weld slag comes off fairly easy, and we've got a consistent looking weld bead, uniform. Good washing. And there we have it. Now, wrapping up on what we talked about for troubleshooting, we started off with our travel speed too fast, too slow, and then our current too high, too low, and then we changed our arc length from too long to too short. And again, as we mentioned earlier, that reading that puddle is going to tell us exactly what's going on with that puddle and what we need to change. Now, based on this information, once we get done, you can look at your weld, evaluate it, and see which one of those variables you need to alter to make your weld come out better. If you want any more welding information, you can visit lincolnelectric.com.